right, so we're going to talk about number theory, primes, and composite numbers. So the first thing we want to understand is natural numbers. So natural numbers are the first numbers that you learn to count with. 1, 2, 3, 4, 5, 6. So those are our natural numbers here, okay? So divisibility, if A and B are natural numbers, A is divisible by B if the operation of dividing A by B leaves a remainder of 0. So it kind of looks like this. This is the symbology of it. B dividing A. So 24 is divisible by 12. That's a true statement. 13 is not does not divide into 24. Okay, so that's just kind of some symbology there, just kind of to see, look at. So a prime number is a natural number greater than 1 that only has itself and 1 as factors. So 2, 3, 5, 7, so on and so forth. Those are prime numbers. Those are their prime factorization. So a composite number is a number greater than 1 that is divisible by a number other than itself in 1. So for example, 9. 9 is a composite number because 3 times 3 gives us 9. So it has other factors besides just 1 and 9. Fundamental theorem of arithmetic. Every composite number can be expressed as a product of prime numbers in one and only one way. Now that is disregarding order. So for example, if I had 12, I could really say that is 2 times 2 times 3, but what I'm saying is this is the only way we can write it. These are the same thing, okay? So order does not matter. That's what we're kind of going to disregard there. So what we're going to do is we're going to look at factoring here, and I'm going to show you a factor tree. That's what your book is kind of showing out there. So I'm going to show a factor tree, and I'm going to use that factor tree to find the greatest common divisor and the least common multiple, okay? So the first thing is I better understand how to factor, okay? So the nice thing is because order doesn't matter, a lot of times it doesn't matter where you kind of start with. You could probably look at this and say, oh, okay, well, there's something that divides in there. I know there is. What it is can change. Like somebody might see here and go, oh, well, I see 2 divides into that. Absolutely, it totally does. Somebody else might see that a 7 divides into that. And so what we're going to do is I'm going to just pick 1. I'm going to go that this is 7 and 100. Well, now I know 100 has factors. And yes, I'm probably the one that most people are thinking of as 10 and 10, which is fine. You can pick 10 and 10 because 10 does factor, but I'm going to pick 2. 2 and 50. And then I see that 50 is factorable, so I'm going to factor that as 2 and 25, and then 25 gets factored into 5 and 5. So 700 has these factors in it, 7, 2, 2, 5, 5. So I could write 700 is equal to 7 times 2 times 2 times 5 times 5. Okay? If you were to pick, so let's kind of go back here. And let's say you did pick 10 and 10. And that's fine because now I look here at 10 and 10 and this factors into 2 and 5 and this factors into 2 and 5. Did I get the same thing? Yes. So as long as you continue to factor, and we always take the numbers on the outside here. So I'm going to erase this to give myself a little bit of room here. All right, so I'm going to look here. I see 216. So I'm going to factor this, and this says the greatest common divisor, okay? So when I factor this, I do see that that's an even number, so I'm going to go ahead and divide by 2. That's 108. This is also an even number, so I'm going to divide that by 2 and get 54. Even again, so 2 and 27. That's 3 and 9, and that's 3 and 3. So these are all my factors here. I have 2 times 2 times 2 times 3 times 3 times 3. So I have here's what 216 is. So I'm going to do the same thing with 234. I notice it's an even number, so I'm going to go ahead and divide that by 2, and that gives me 117. Okay, so now I'm going to divide that. This is not even, so I'm going to go ahead and divide that by something else. I notice that this is divisible by 3, so kind of a shortcut to tell if it's divisible by 3 is just add the digits. 1 plus 1 plus 7, that's 9, that's divisible by 3. So this becomes divisible by 3. So this gives me, let's see, 3 and 9. So 39 is 3 and 13. Okay, so now I look at, to find my greatest common divisor, is I look at what they have in common. So here I have 2 times 3 times 3 times 13. Well, notice here that I have this is the same as this. Okay, so I have 2 times 3 times 3, and that's the same in both ones. So that's my greatest common divisor. My greatest common divisor now is 2 times 3 times 3, or this is 6 times 3 is 18. So 18 is my greatest common divisor here. Okay? So what you're going to do is you're going to factor these out completely, write the factors all out, and pick what they have in common. Multiply it out. That's going to be your greatest common factor. Okay? So now our least common multiple. Okay. So when I do this, I have to do the same thing. So I have to factor this whole thing out. Okay. So I'm going to give myself a little bit more room here. So 144, I'm going to factor that out. Okay. Now, a lot of you looked at that and went, oh, 144, that's 12 times 12. Okay. And that's fine. You can do it that way. I could have picked 2 and 72. I'll just pick 12 and 12, because that's probably the one that popped into your head first. Well, 12 breaks up into 2 times, let's go 3 times 4, 3 times 4, and then 4 breaks up into 2 times 2 and 2 times 2. If I would have done 2 and 6, I would have gotten the same thing. So 144 is 2 times 2 times 2 times 2, so there's 4 2's there, times 3 times 3. So this is 144 factored. Now I'm going to come over here and I'm going to factor 300. Well, I'm going to go 3 and 100 just because that makes it a little easier here. I'm going to go 10 times 10, and then this is 2 and 5, 2 and 5. So now if I factor this out, I have 2 times 2 times 3 times 5 times 5. Now, when we're doing this, our least common multiple has to take into account all of the pieces. Okay? So notice here that I have 4 2's here, 2 3's here. Okay? So it has to have 4 2's in it. Okay? So this one has to have 4 2's in it. So my least common multiple has to have 2 times 2 times 2 times 2. Okay? And then I look at my 3's. Well, it has to have that many 3's in it. Okay? 3 times 3. And then it has to have this many 5's in it. 5 times 5. Now, if I multiply that all together, 2 times 2 times 2 times 2 times 3 times 3 times 5 times 5, I get 3,600. Okay? And that is my least common multiple for 144 and 300. So make sure that you look at these factorized pieces here. You have to take all of them. Now, if I was trying to find out what I'm going to multiply this by, well, I'm actually only going to multiply it by the pieces it's missing. So 2 2's and a 3. So I'm going to multiply 300 by 2 times 2 times 3. Here, I'm missing 5 times 5. So I'm going to take 25 times 144. So that is kind of a brief, quick thing on factorizing and kind of natural numbers.